Hello again, everybody. This is Joseph. This is actually part 3 of how to test and understand the basic concept of an alternator, how to measure the output, not just the voltage, but the current. As in the previous 2 videos, I described how the alternator and the battery work together, and therefore there's a regulator involved in the alternator to keep the voltage constant. As you saw in my demonstration when I did in the video, I measured the output of the alternator. I was expecting to get 13 to 14 volts, which I did. The regulator role is to keep the voltage constant regardless of how many loads you put on it, including accessories, headlights, alarms, or other things. So therefore, my first objective was to measure 13 to 14 volts DC. As you'll see in the video before it, I did measure that, and I measured that with this meter, which you saw was around 14 something, 14.6, 14.7. I had it on 20 volts DC, as you see over here, volts DC, 20 volts. You could put it on 200 volts also. You can't put it on 2 volts because you could expect more than that. So that was my first objective, which was correct. Second thing was, as we spoke about before, I wanted to measure something called the current output of the alternator. That hasn't been seen before on YouTube. Usually just the voltage is measured while you put the accessories on and see how the regulator is doing inside the alternator. This is the regulator, as I described before. And please subscribe to my channel of Automotive Electronic Schematics by Joseph. Now, my first objective was to put on the headlights, not crank the engine. What was the purpose of that? Well, I wanted to see just the battery, just putting on the switch of the headlights. I wanted to see how much that would draw current from the battery. It measured about 15 amps, which I have here with no engine. Battery output with no engine of 15 amps. Now, I cranked the engine. When I did crank the engine, as I specified before, in order to have output of the alternator, first you have to obviously crank the starter, crank the camshaft, the crankshaft, fuel and spark from the PCM into the fuel injection has to happen. That's the purpose of the battery, to start off that. Once that gets going, the crankshaft turns, camshaft turns, the belts turn, the serpentine belt turns, and the alternator turns, which is the rotor, the stator, producing AC. Then you have, as I specified before, 3 Zener diodes and 3 rectifier diodes to produce the output of the alternator from AC to DC. And we want DC because we have to recharge a battery, which is DC. DC goes here, as I explained before. DC goes to the regulator to tell the PCM, the computer, how much the output of the alternator is. Again, the alternator will either increase or decrease the field current of the rotor to either give more current or less current and to keep the voltage constant. And I'll specify that in another video, go into more details. However, my experiment was to show to the viewers without any crank, no alternator going, just putting on the headlights, battery output was 15 amps. When I started cranking, the output was around, alternate output was 23 amps. When I put the headlights on, which is a load for the alternator, my output of the alternator, which is this wire, I put this meter, which I showed you. This was, as you can see, there are 2 scales, 40 amps, 200 amps. I was safe to put it on 40 amps or 200 amps, as I said. As you can see, this tells you in amps. And when I did that, when I put the headlamps on, front and forward, then I went from 23 to 37. Why did I get 37? Well, because I wanted to know how much current had to feed the headlights, the headlamps, and the battery and the accessories. Well, I was expecting 15 amps, and that's for sure what I measured. So 23 plus 15 is around 38, 37. The output of the alternator, which I went right here, battery output. Right here I measured, as I showed in the video. So it's not enough just for me to measure the constant regulator output. I still want to see the current, and I want to see how much current is being given and drawn by the battery and other accessories. That is one experiment or a source that is very efficient and very informative to me about diagnosing and troubleshooting. So I went up from 23 to about 37 with the headlights on, giving me and proving my theory, so to say, that the PCM is getting the input, meaning that he knows accessories are on by the serial data of body control module, which gives the relays and the grounds for the headlamps in this Chevy. It told the PCM reacted by producing more current in the field rotor. So I know the PCM is working correctly, I know the regulator is working correctly, and I know the battery inside this is working correctly. So therefore, as I specified before, that was what I wanted to show you. It is in the previous two videos, and like I said, it's just not enough to measure the output, the voltage, to see if it's constant. I want to make sure how much amps is being given to the battery and to the power distribution, which officially goes to the headlamps, in this case to the load, to make sure how much current is being given out by the alternator. And that I did by this, clamping this. This is one of the best meters, I believe. Not that expensive. As you can see, measures voltage, voltage DC, voltage AC, hertz, which is 60 hertz if you're measuring the 120 volts RMS of your outlet. And the scales are safe enough. Goes up to 200 amps, as you see, DC. Problem with this one, though, this type, as you can see, goes up to 200 amps, and it goes to 10 amps. That's it. So if you're going to measure, or put it in series, if you're going to measure more than that, more than 10 amps, you blow the fuse. Not safe. The only thing that is safe is using this one, which I demonstrated with. Up to 200 amps, you are safe. And you know, with accessories and all that, you're not going to even pull that much. On the when you do crank, you could pull, depending how many cylinders you have, maybe 200, maybe 300 amps. When you with the starter, depending how many cylinders you have, I would use a more higher scale clamp meter, not this one. But for all potential service ideas and this situations, this did suffice enough. 200 amps was more than I needed, and it's easy. You don't have to break the circuit. All you do is claw it around the alternator output. Easy as that, and accurate. Thanks for watching. Please subscribe to my channel, Automotive Electronic Schematics by Joseph. I need about 1,000 views. I'm way off from that. 1,000 subscribers, I'm sorry, and 240,000 minutes. Don't know if I ever reach that by November, but I keep on trying. I thank the comments, and please leave comments. I will make more videos, probably hands-on, so you get a better idea. But first I want to explain the theory before I go out there and do it, so people understand what's going on. And please subscribe to my other channel of Joe Electronic Schematics for Auto, which is for, I guess, students in technical colleges or something, which is schematics, how to read schematics, how to understand schematics, transistors, the foundation, the basic foundation. I thank all the viewers for their comments. They are much appreciated, whether negative or positive. Everything is appreciated. Thanks for the dedication to the viewers. Thank you.